Let's now put together the concepts we've just learned about two-dimensional motion and forces that involve the gravitational potential energy. We're going to use a box. Here's the box. And it's being pushed up an incline in this direction. And the displacement is going to be d along the incline. And after we get done pushing it, it'll be a height above the ground here, h. Now it all depends on what's easier for us to measure to determine its potential energy. In this case, let's assume it's easier to measure the displacement d. How do we find its change in GPE? Let's assume the box starts at rest from the bottom of the incline down here. It gets pushed up d and then momentarily stops here. So we're going to analyze the initial position here compared to the final position here, where the kinetic energy in the beginning and the end are both zero. So, does the change in gravitational potential energy equal mg times its displacement? No. The formula for the change in gravitational potential energy, and a lot of times we leave out the delta. That's probably not great, but we just do it to save time. We calculated that from the work formula, where we assumed that the gravitational force, or the force that was being used to lift the object, was in the same direction of the object's motion, so we could use that displacement. In this case, the gravitational force points down. Work only includes the distance and force components that are in parallel. So in this case, what we need to find the change in gravitational potential energy is the height here. That is the relevant variable. How do we get that if we've measured d? So we know that the change in gravitational potential energy is mgh. Okay, here's h, here's our formula. Now we need to find the change in height related to d and theta. We will use trigonometry. The sine of theta is opposite, which is h, over the hypotenuse, which is d. So we have sine theta equals h over d. We rearrange that, so h is equal to d sine theta. We now take this value of h, put it into this equation here, and we come up with the change in gravitational potential energy is mgd sine theta.